Welcome back, folks. So this is just going to be a video about some stuff I got in the mail and what projects it applies to and updates on those projects. So these three cords here, I got these. I thought I had something that would be suitable for my project regarding the power fail safety switches, but they didn't turn out to be. But I did find these 1 meter long AC power cords that I can use for that purpose. They're just perfect for it. And I also decided for that project is to add in some toggle switches so that if I want I can flip the toggle switch and shut down that particular circuit if see a thunderstorm coming or something like that. Rather than allowing first power failure to come, I can disable it and come back on, turn it back on, and hit the button, and away she goes. So yeah, so this completes all the materials I need for this project. I have the 3 boxes, the 3 relays, the 6 switches, and now the 3 cords. So look forward to an upcoming video on that. So I got this this wire here. Now this is supposed to be really nice silicone wire. And it kind of feels like silicone, but my guess it's not really silicone. I think it's probably more like this. A very low temperature rating on it, 200 degrees C. Silicone will be a bit higher than that. But I think it's some of that rubberized PVC, but it's really nice and flexible. It'll make a really nice hookup wire for putting together projects. So I'm going to try this out. This is I believe 22 gauge. Yeah, 22 gauge for small current stuff. And look at this. They give you some nice little tie wraps of all the different colors that you have in here. And it comes, yeah, so 6 different colors. And yeah, this is really nice stuff. I'm going to I'll let you know how it works out in a video where I get to use it. But the box is also a dispenser, so you just bring the wires through, and it's a handy little thing. Yeah, I don't know how much I paid for this. I think it was only it was less than $40 for the lot, so that wasn't bad. We'll see how it works though. I mean, mostly I'm concerned with it being nice and flexible and easy to tuck in, and being able to withstand solder temperature without insulation burning or melting off, which is a real pain in the butt. I have my doubts, but we'll see. Yeah, I know what this is. I don't get much from Mauser, so this one stands out, and it has to do with my pump project, which I talked about in a recent video. A box within a box within a bag. An anti-static box too. Wow. Interesting. And anti-static foam. And here we have pressure switches. These are NXP solid state pressure switches or pressure sensors. They provide an analog output depending on the pressure that's across them. These particular models work from 0 psi up to about 80 psi. I generally run my water around here around the 35 psi range. So that's right in the middle of the range for these things. But what tends to happen is you get the sensor and you bring it down to the pump through a hose. And initially when you set it up, there's an air gap in the hose, and the liquid doesn't touch the sensor. Now, liquid touching the sensor is not a bad thing. It's not going to kill it, except for we're dealing here with groundwater, so it's very, very high in minerals. And eventually what happens is that air gap through osmosis, and it doesn't take long when you're under a couple of atmospheres of pressure, it doesn't take long for that air gap to completely disappear or completely get absorbed. And the water begins to touch the pressure sensor. And over time, it's not quickly, but about every 3 years or so, enough gets deposited on the sensor. The sensor just doesn't respond properly, and the pump misbehaves, and it has to be replaced. Now, what I'm thinking I'm doing, I normally used to buy these off eBay. I used to get them for around about $10, but I had to go to Mauser to get them now. So I ordered a bunch of them to keep me going for a while. And does it say on here the price? Yeah, I think it works out to about twice that. It's about $19 to get them out of Mauser. But what I'm thinking I will do is that when I install this, I'll use some sort of benign oil, like a silicone oil or something like that. Just a drop of it to maybe take up an inch in the tube so the water comes up to it, and then osmosis won't occur into the silicone oil. And I'll try that to see if that works. So that should keep the air gap there. We'll see when we get there. Right now, I did have to change it after I got back from my little vacation. I did change it out with one I had, and I ordered these ones in to replace that. So, yeah, and when I build up that project properly, I'll come back to that at that point in time, and we'll address this situation with these sensors and how I'm going to keep the water away from the membrane in the sensor. All right. Okay, this looks like something from PCB. Best way to get into these. They've gone away from the envelopes now, I think, entirely to the tape method. I guess it saves them some money and still provides some security. Although I'm sure if customs want to get into it, they'll make a mess of everything. And every now and then, for some reason, they do want to get into things. There we go. And there's the ubiquitous pen. The last one they sent me was cracked. Yeah, this one is too. So they're great pens, actually. You know, they write very well, but the problem with them is the barrel here tends to crack a little bit, and this part here won't tighten up on it. So you got to put some tape around it or something like that. Or I tried gluing it, some of that Gorilla Glue on it, and I left it down like this. And unbeknownst to me, somebody else came along and put the cap on it and put it away. And of course, it just, yeah. That's a thing. Okay, so we got in here the boards for our second transistor project. This one here is a little single transistor Class A amplifier. And I'll do the video on that probably on Thursday. We'll build up a couple of these because I also want to show how you can put them together in stages. But yeah, there it is. Yeah, 5 boards. 5 boards, $5. Okay, this is not a sponsored video, but this came in the mail. I just thought I'd show it to you. So we'll come back on Thursday and we'll build up a couple of these and have some fun with that. This package here. I'll put links to most of this stuff if I can down in the description. So if you're interested at all in getting any of this stuff, you can. Okay, yeah. So these are for my wall wart eliminator project, which is actually turning out to be quite expensive. Like, I think that I've got everything for it now, except for the panels. Panels have been paid for and they're on their way. I just received an email this morning that they're being shipped. These here are the DC jacks. They're panel mount DC jacks. I contacted the supplier and I got them to measure the diameter of the barrel here. And I'll show you in a minute what I came up with as far as panels go. But he provided that information. It turns out that they're 11.5 millimeters, so a 12 millimeter hole is perfect for them. They then complete. So they come as so each bag of 10 comes with a plug and a little cap to go over it. So this kind of mounts into the panel with this little cap over it. I don't know how useful that's going to be. I mean, if you wanted to firmly mount it into the panel, the way I've designed the panel is that it's a PCB, and on both sides of it is a ground plane and there's plated through hole on it with enough of an area, enough of a land so that you can make good electrical contacts and make it easier to wire up. But having this there, although it, look kind of neat, will make that contact a little bit less, because there's only so much you can squish that rubber before you destroy it. So you can't really tighten this thing down enough, and you're missing one of the contacts. So I think I'm probably not going to use these little rubbery things. I'll use them for something else. But these are handy. It's going to be handy in making up the cords to all the various different devices. And in case you don't know what I'm blathering about, I did talk about it in a previous video briefly, but let me talk a little bit more about it here. I'll clean all that up. So this is basically the project here. This is IEC power entry. I've got a couple of these Morrison power modules. I've got 5 volts at 10 amps, 12 volts at 6 amps, 9 volts at 6.5 amps. I'm going to put in one of these EMI filters, which I featured in a video recently. I tested it out to see what its frequency response is, and it looks like it's going to be pretty good. I have this nice cabinet for which I've got nice black, matte black, well, I don't know if they're matte black, semi-matte, satin black PCBs as panels being made out for both the front and the rear. And I got these little panel meters, voltage and current. So I'll do the one for the 5 volts, the 9 volts, and the 12 volts. Now what I'm going to do, and I'll show you on the panels in a minute, is that I'm going to have like 2 outputs on the front for each voltage, and there's going to be 4 on the back for each voltage. So it'll be 6 for each voltage, and that will more than replace what I have here as far as wall warts are concerned. Altogether too many of them, I hate the things. And allow me some room for expansion into the future, and also the front ones for if I have to plug something in just momentarily, like an Arduino or something like that. I can plug it into the 9 volts and use it for a while and then take it out. But I think it's going to be a handy addition, even if it turned out to be really more expensive than I really wanted it to be. But yeah, so that'll be all built into this nice cabinet here. And I'm looking forward to completing that and tidying up my bench. And I've got all these outlets at the back here. About a third of them are taken up with stupid wall warts. It's ridiculous. And this will just have one. I'll replace all those with one. And the problem with wall warts is they take up more than one space. Even these power bars that I have here, they've got like about 2 inches of spacing between each outlet. And still, the bigger wall warts consume all that space. So sometimes when you plug one in, you lose 2 spaces rather than just one. I hate wall warts. I mean, they're so bad. They're noisy. They have leakage voltages and everything else. And I'm going to do certain things like using type Y capacitors to earth ground to eliminate or reduce or control those parasitic voltages, those leakage voltages. These Morrisons are not known for them. I mean, they're usually, down around about a volt or 2, but using the Y-type capacitors, you can get it down to less than 1/10 of a volt, which is where I want to be. Okay, so here's a look at the panels for our wall wart eliminator. We've got the front panel here. You can see it's going to have the 3 meters and 6 outlets. 2 for 5 volts, 2 for 9 volts, and 2 for 12 volts. And you can see around here, I've got the LANs are big enough to fit those DC power jacks that I showed you and provide full contact front and rear into the ground plane. So there's a ground plane over the entire back and over the entire front. And they are connected together through these plated through holes here. So that should simplify the wiring a little bit. And it's going to be black. So this is the rear panel with the main distribution. We've got 4 outputs for each voltage, and room for a fuse here, and a cutout here for the IEC connector and switch. I sent this off with 250 milliamps written up here. So I don't know what went on that day, but yeah, I missed that little thing. But that's not a big deal. I'll just put a little sticker over it. But I have received news that these are on their way to me. We'll build this thing up. I don't know how many videos that'll take, maybe just the one, but maybe 2. There's going to be quite a bit of wiring, and I got to figure out how I really want to do that to make the lowest possible impedance getting to and from the power supplies and the outputs. But again, this is it's ground plane on both sides, or copper core if you prefer. These plated through holes here where the connector is going to go, and the 2 sides are interconnected with the plating through the holes. So that should provide a good low impedance path for the ground anyway. I'll get on this when it comes in. My next project, as I say, is going to be that little one for PCB way where we do the Class A transistor amplifier. and that should happen on Thursday. You know, as we're speaking today, it is July 31st, which means we're pretty well halfway through summer, and I'm going to have to get prepared for winter. It's going to cut into my time a little bit, so I don't know how many weeks I'm going to be able to do 3 videos a week, so I might cut back to 2, and sporadically, if I have time, I'll do a 3rd video on the weekend. But I've got not just this house to worry about getting ready. I've got another house which is currently being rented out, and it's not winterized, so I've got a big project there to winterize that place because they want to stay there during the winter. And anyway, enough of my troubles. Thank you very much for joining me today. I really appreciate it. If you like any of the stuff I do, please leave a like. Subscribe if you want to see more. And if you got any value out of anything I do, you can always, there's a link down there in the description. You can buy me a coffee. I'd really appreciate it. I'm a very heavy coffee drinker. All right, guys. Thank you very much. We'll see you again. Bye.